Welcome to The Midnight Physicist, the place where the mysteries of the universe unfold under the cover of night. Whether you're winding down or just curious about the cosmos, join me on a journey through the infinite wonders of space and time. Let's explore the stars, quantum realms, and the very fabric of reality, all while you relax and drift into the mysteries of the universe. So, sit back, relax, and let's dive deep into the cosmos. Time travel has long been a subject of fascination and intrigue for humanity. The very idea of moving through time, whether traveling to the distant past or leaping forward into the future, has inspired endless works of science fiction, from books and movies to television shows. But while these stories have become a staple of popular culture, one question remains: is time travel merely a product of our imagination, or could it one day become a reality? The concept of time travel first entered the realm of science fiction in a serious way through H.G. Wells' groundbreaking novel The Time Machine, 1895. In this iconic work, Wells introduced the idea of a machine that could transport a person through different points in time, bypassing the typical constraints of linear time. For readers at the time, this was a revolutionary idea that opened up a world of possibilities. It was a concept so alluring that it continues to influence our thinking about time travel to this day. Wells was not just imagining a fantastical future, but exploring the possibilities that science might one day unlock. But of course, time travel is more than just fiction. Over the years, the idea has shifted from an element of fantasy into a subject of serious scientific investigation. The idea that time itself is not as fixed or linear as we once believed has inspired numerous scientific theories and models. In the simplest terms, time travel can be defined as the ability to move between different points in time, just as we can move through space. Instead of being confined to the flow of time that we experience on a day-to-day basis, time travel would allow us to traverse time in any direction, backwards to witness historical events, forwards to see how our world evolves, or even to different timelines entirely. Now you might be wondering, why are we even discussing time travel in a scientific context? After all, time travel as portrayed in movies like Back to the Future or Doctor Who often involves fantastical, futuristic machines and adventures that defy the laws of physics as we know them. So, what's the connection between these fictional portrayals and the serious scientific discussions happening today? Well, the short answer is that time travel could actually be possible, at least in theory, according to the laws of physics. The primary reason for this is the relationship between space and time, which is central to Einstein's theory of relativity. According to Einstein's equations, space and time are intertwined in what is called the fabric of space-time. Imagine space-time as a fabric stretched across the universe. Any mass, such as a planet, star, or even light, can warp or bend this fabric. This warping or curvature is what causes what we perceive as gravity. But what does this have to do with time travel? Einstein proposed that if an object could travel at speeds approaching the speed of light, or if it were to enter a region of intense gravity, like near a black hole, time itself would behave differently. In essence, the closer an object comes to the speed of light, the more time slows down for that object relative to an outside observer. This phenomenon is known as time dilation, and it's been proven in experiments involving high-speed particles and even astronauts traveling at fast speeds in space. This suggests that, if we could somehow reach speeds close to that of light or manipulate gravity in a certain way, it might be possible to slow or even reverse the passage of time for a person traveling at those speeds. But what about traveling to the past? Could we go back in time to witness historical events, perhaps change them, or even visit different versions of ourselves? This idea is much trickier and is largely tied to another concept known as closed time-like curves, CTCs. These hypothetical paths through space-time would allow an object to loop back on itself and travel to a previous point in time. While Einstein's equations don't rule out the possibility of CTCs existing in the universe, there's still much we don't understand about how such a phenomenon could work in practice. The idea of time travel is not just confined to scientific theory, however. Over the past few decades, physicists and engineers have speculated on potential ways to create practical time machines, or at least experiment with some of the principles that might one day make time travel possible. In fact, there are several models and theoretical mechanisms that have been proposed, such as wormholes or cosmic strings, which could allow for time travel. But as of today, these concepts remain purely hypothetical, and the technology needed to manipulate the fundamental forces of the universe is still far beyond our reach. Despite these obstacles, time travel is a concept that continues to capture the imagination of both scientists and the general public. It challenges our understanding of the universe, forces us to reconsider our perception of time, and opens up endless possibilities for exploration. So, what exactly does the future hold? Could time travel one day be more than just a theoretical possibility? As we dive deeper into the concept of time travel, one crucial question that arises is, how does time travel work according to the laws of physics? We've already touched on the idea that time is not as simple as it seems. Time is intrinsically linked to space, forming what we call space-time. But how do we actually manipulate or travel through this complex construct? Let's begin with one of the most important theories in modern physics, Einstein's theory of relativity, both the special and general relativity theories. These theories revolutionized our understanding of space and time in the early 20th century, and they provide the foundation for many of the ideas behind time travel. The special theory of relativity, proposed by Einstein in 1905, tells us that the laws of physics are the same for all observers, no matter their speed, as long as they are not accelerating. It also introduced the idea that the speed of light is constant for all observers, no matter how fast they are moving relative to the light source. This might sound simple, but it has profound implications for our understanding of time. One of the most surprising predictions of special relativity is the concept of time dilation. Time dilation means that as you move faster through space, time itself slows down for you compared to someone who is at rest. If you were traveling at near the speed of light, time would pass much more slowly for you than it would for someone standing still on Earth. This means that, in theory, an astronaut traveling at relativistic speeds, close to the speed of light, could experience just a few years of travel, while decades or even centuries might pass on Earth. This effect has actually been tested and confirmed. High-speed particles called muons, created in cosmic rays, decay much slower when they are moving at speeds near the speed of light. Similarly, astronauts on the International Space Station, ISS, experience a slight amount of time dilation as they travel at high speeds relative to Earth. Their clocks run slower, albeit by just a tiny fraction of a second, but it's proof that time dilation is real. This brings us to the idea of traveling to the future. Based on what we know about time dilation, traveling forward in time might actually be achievable with current technology, at least on a small scale. For example, a spacecraft traveling at a significant fraction of the speed of light could allow its passengers to travel forward in time by many years compared to people on Earth. However, this doesn't mean you can just hop into a time machine and instantly jump into a far-off future. The practicalities of reaching these speeds remain a significant challenge, as we don't currently have the technology to propel spacecraft at such high velocities. Now let's talk about general relativity, which expands upon the ideas in special relativity to include gravity and acceleration. One of the key predictions of general relativity is that massive objects, such as planets and stars, cause a curvature or warping of space-time. This is what we perceive as gravity. So, what does this have to do with time travel? General relativity introduces the concept of time dilation due to gravity. The stronger the gravitational field you're in, the slower time will pass for you compared to someone further away from the massive object. For example, time moves slower near a black hole, which has an extremely strong gravitational field. If you were near the event horizon of a black hole, time could essentially freeze for you, while the rest of the universe would continue to move forward. This idea suggests that it might be possible, in theory, to travel to the future by spending time near a massive object like a black hole, where time would pass differently for you. However, the challenges are immense. Approaching a black hole would be incredibly dangerous. Not to mention that once you cross the event horizon, there's no turning back. But black holes aren't the only places where time dilation occurs. Another fascinating idea that comes from general relativity is the concept of wormholes. Wormholes are hypothetical shortcuts through space-time, which could connect distant parts of the universe or even different points in time. If a wormhole could be created and stabilized, it might allow someone to travel to the past or the future instantly. But like black holes, the existence and practical use of wormholes remain theoretical. While these concepts might seem incredibly complex, they're all grounded in established physics. The equations are there, and the theories hold up in specific scenarios. The real challenge comes in applying them on a scale that would allow us to actually use them for time travel, creating a stable wormhole, traveling near the speed of light, or surviving the intense gravity near a black hole are problems that we currently don't know how to solve. We've discussed how time dilation could theoretically allow us to travel into the future. But what about traveling to the past? Can we reverse the flow of time and revisit moments from history? This is where the science of time travel gets even more speculative and complex. While traveling into the future seems possible through time dilation, traveling backward in time presents a set of paradoxes and challenges that make it far more difficult, if not impossible, according to our current understanding of physics. One of the most famous thought experiments regarding time travel to the past is the grandfather paradox. The paradox is simple, yet profound. What if you traveled back in time and prevented your grandfather from meeting your grandmother, thereby preventing your own birth? If that were to happen, how could you have traveled back in time in the first place? This creates a logical contradiction. If you weren't born, you couldn't have traveled back in time to interfere with your own birth. The grandfather paradox illustrates the fundamental problem with time travel to the past. It threatens to create contradictions in the timeline that challenge our basic understanding of causality and the sequence of events. Despite this paradox, there are some theoretical models that propose ways in which backward time travel might be possible. One of the most well-known is the concept of closed time-like curves, CTCs, which was first suggested by physicist Kurt Gödel in 1949. A CTC is essentially a path through space-time that loops back on itself, allowing an object to return to its starting point in time. In a sense, a closed time-like curve would create a kind of time loop, where the past and future are connected in a closed cycle. In theory, if a time traveler could navigate such a curve, they could travel to the past. However, there's a major caveat to this idea. The existence of CTCs is still purely speculative. While Einstein's equations of general relativity don't rule out the possibility of closed time-like curves, there is no experimental evidence to suggest that they exist or could be created. In fact, many physicists believe that CTCs may not be physically possible because they would violate the principle of causality, the idea that cause precedes effect, and that events cannot occur in an order that defies logical consistency. Another potential mechanism for time travel to the past involves wormholes. A wormhole, often described as a tunnel through space-time, connects two separate points in space and time. If such a tunnel could be created and stabilized, it might theoretically allow someone to travel through it to a different time, perhaps even back to the past. The concept of a wormhole comes from Einstein's theory of general relativity, which allows for the possibility of shortcuts through space-time. However, like CTCs, wormholes are purely theoretical and would require exotic forms of matter with negative energy density to remain stable. Without this exotic matter, a wormhole would collapse before anything could pass through it. But even if we could travel to the past, there are still fundamental questions about whether changing the past would be possible. If we look at the quantum mechanics perspective, we encounter another paradox known as the many worlds interpretation. According to this theory, if you were to travel back in time and alter an event, such as preventing your grandfather from meeting your grandmother, you wouldn't be changing the original timeline. Instead, you would be creating an entirely new timeline, one in which you were never born. This theory posits that every action, no matter how small, could create an alternate reality, meaning that time travel to the past might not erase or alter the original timeline, but create a branching multiverse of possibilities. But these interpretations and models, while intriguing, remain purely theoretical. We have no current method or technology to manipulate time in such a way that we could travel to the past. The concept of creating and maintaining a wormhole or closed time-like curve is far beyond our current understanding and technological capabilities. More importantly, The paradoxes and contradictions associated with time travel to the past, such as the grandfather paradox, present profound challenges to the idea of changing history. While time travel remains an intriguing concept, several significant obstacles make it practically impossible with our current technology. These obstacles primarily concern the energy required, the curvature of space-time, and the complexities of quantum mechanics. Let's break them down further. Energy requirements. One of the greatest challenges of time travel is the enormous amount of energy required to manipulate space-time in such a way that time travel could be realized. The theoretical model of wormholes is one of the most discussed avenues for time travel. Wormholes are essentially hypothetical tunnels through space-time that could connect two distant locations in space and time. If such tunnels could exist and remain stable, they might allow for time travel. However, stabilizing a wormhole would require a type of matter called exotic matter, which is theorized to have negative energy density. This exotic matter would be needed to prevent the wormhole from collapsing under the immense gravitational forces it generates. Unfortunately, no known form of exotic matter has been discovered yet, and even if it were found, the amount needed to create and stabilize a wormhole would likely be far beyond anything we can generate today. The energy required for such a feat is on the order of the total energy output of entire stars or even entire planets. To put it into perspective, the power required to create a wormhole could dwarf the capabilities of any current or foreseeable power source. This presents a massive hurdle for the possibility of time travel through wormholes. Space-time curvature. In addition to energy constraints, we also have to understand space-time curvature. Albert Einstein's theory of general relativity tells us that massive objects like stars and black holes warp or curve space-time around them. This curvature is responsible for what we perceive as gravity. While we can observe this curving in action, it's much harder to manipulate it for practical use. For instance, black holes are regions of space where space-time curvature becomes so extreme that not even light can escape. As an object gets closer to a black hole's event horizon, the fabric of space-time is so warped that time itself slows down for the object. This phenomenon is called time dilation, and it offers a potential window into time travel to the future. However, while the time dilation effect near a black hole could theoretically allow us to travel to the future, the practical difficulties of approaching a black hole are immense. The tidal forces near a black hole, caused by the gravitational pull from the object, are so intense that they would tear apart any spacecraft, a process known as spaghettification. Additionally, the radiation around black holes would make it nearly impossible for any human or machine to survive. Even if we could avoid these hazards, the irrevocable journey once past the event horizon means we would never be able to return to our original time. So, while black holes are fascinating and are integral to understanding time dilation, they are far from a practical solution for time travel. Quantum mechanics. On a different scale, quantum mechanics provides another avenue for exploring time travel. One of the more intriguing phenomena in quantum mechanics is quantum entanglement, in which two particles become linked, meaning the state of one can instantaneously affect the state of the other, no matter how far apart they are. This mysterious connection has led some to speculate that it could be used for faster-than-light communication or even manipulation of time. However, while entanglement is an established phenomenon, using it for practical time travel is still theoretical and faces numerous hurdles, not least of which is maintaining the entanglement over vast distances and timescales. Another important idea from quantum mechanics is the many worlds interpretation, which suggests that every time a quantum event occurs, it creates a branching reality, essentially an alternate timeline. So if you were to travel back in time and alter an event, such as preventing a historical figure from doing something significant, you wouldn't necessarily erase the original timeline. Instead, you might create a new, parallel reality. This idea presents a challenge to the very nature of cause and effect, and raises more questions about what changes in the past could truly mean for the future. While these quantum phenomena might offer insights into how time travel could function, the practical applications are still far from clear. The quantum world is vastly different from the macroscopic world we experience, and harnessing these principles to travel through time remains speculative, theoretical versus practical time travel. Although the laws of physics, as we currently understand them, seem to permit the possibility of time travel in theory, the practical constraints, energy, gravity, and quantum behavior, are enormous barriers. Creating a stable wormhole or surviving near a black hole are challenges that stretch our imagination and capabilities. Additionally, quantum mechanics introduces a level of complexity that complicates the idea of time travel even further. As we push the boundaries of science and technology, it's possible that one day we will unlock the answers to these questions. But for now, time travel remains a concept more rooted in theoretical physics than in reality. Having explored the challenges of time travel, from energy constraints to the complexities of space-time curvature, it's important to turn our attention to one more crucial question. What would time travel actually look like if it were possible? While we've discussed the theories and obstacles, it's fascinating to imagine the practical aspects of time travel. How would it function, and what kind of technology would we need? If time travel were possible, it would likely require the development of technologies far beyond anything we currently possess. The most popular method often imagined in science fiction is the time machine, a device that allows a person to travel freely through time. But what kind of technology might we need to make this possible? 1. Time travel via wormholes. One of the most promising avenues for time travel involves wormholes, as we discussed earlier. In theory, wormholes could create shortcuts through space-time, allowing you to instantly travel to distant points in time or space. But how could we create and use them practically? The first challenge is that wormholes are purely hypothetical and would require exotic matter to keep them stable. This exotic matter would counteract the gravitational forces trying to close the wormhole, allowing it to remain open long enough for something to travel through it. While theoretical physicists have speculated about the possibility of manipulating space-time to create these shortcuts, the technology to create, stabilize, and navigate through a wormhole is far beyond current capabilities. Moreover, even if we could stabilize a wormhole, the traveler would need to somehow control its entry and exit points, ensuring they land exactly where and when they intend to. Imagine a futuristic, high-tech control room inside the time machine, filled with sophisticated gadgets, holographic displays, and complex mathematical calculations that would enable the traveler to pinpoint the exact moment in time and place they want to reach. It would require incredible precision, as even a small error could mean arriving in the wrong place or at the wrong time. 2. Time travel via speed of light. Another theoretical method of time travel involves moving at the speed of light. According to Einstein's special theory of relativity, time slows down the faster an object moves through space. So, if a person were to travel at nearly the speed of light, time would pass differently for them compared to people who remained stationary. Essentially, they would be able to skip ahead in time, arriving in the future while only experiencing a short amount of time in the present. This type of travel is often depicted in science fiction as futuristic spacecraft traveling across vast distances at incredible speeds, where the astronauts experience time at a vastly different rate than those back on Earth. While the concept of traveling at near-light speeds is still theoretical and requires enormous energy, the idea is rooted in scientific principles that make it a potential possibility for the future. However, practical limitations are still significant. Achieving even a fraction of the speed of light would require energy levels we can barely fathom. A spacecraft designed to travel at relativistic speeds would need to withstand intense forces and radiation. Not only that, but the effects of time dilation would present challenges in communication and coordination, as time would behave differently for the travelers in motion versus the people they left behind. 3. Time travel via black holes. As we've discussed, black holes are regions of space where gravity is so intense that nothing, not even light, can escape. Near the event horizon, the boundary around a black hole, time slows down significantly. While getting near a black hole would be extremely dangerous, the idea is that a traveler could experience time differently. For example, spending a few minutes near a black hole could allow them to jump forward in time by years, decades, or even centuries. However, as we've seen, the hazards associated with black holes are far more significant than the potential rewards. The spaghettification process would tear any spacecraft apart, and the intense radiation around black holes would likely destroy any technology attempting to get close. Despite these dangers, black holes remain one of the most intriguing candidates in theoretical time travel discussions. 4. Time travel through quantum mechanics. Finally, quantum mechanics might offer a wild card in the race for time travel. As mentioned earlier, quantum particles like photons can become entangled with one another, meaning that the state of one particle is immediately linked to the state of another, even over vast distances. Some scientists speculate that this entanglement might allow for instantaneous communication or influence across time. One idea that's been proposed involves quantum tunneling, a phenomenon where particles can jump through barriers that would otherwise be impossible to cross. Could quantum tunneling be harnessed for time travel? This is still purely speculative, but quantum mechanics presents possibilities that are vastly different from the classical ideas we've discussed. We explored various theoretical methods for time travel, such as wormholes, speed of light travel, black holes, and quantum mechanics. While each of these concepts is deeply intriguing, we must now turn our attention to a more fundamental question. What are the potential consequences of time travel, if it were possible? Time travel is not just about moving through time. It's about the profound impact it could have on reality itself. The consequences range from paradoxes and changes to history to deeper implications on the nature of existence and the fabric of the universe. 1. The grandfather paradox and causality. One of the most famous paradoxes associated with time travel is the grandfather paradox. Imagine you could travel back in time and prevent your grandfather from meeting your grandmother. If you succeeded, your parents wouldn't be born, and by extension, neither would you. But if you were never born, how could you have traveled back in time in the first place? This creates a logical contradiction. The very act of going back in time to change something crucial about the past would prevent the conditions that made your time travel possible. This paradox highlights the conflict between time travel and causality, the principle that cause precedes effect. Causality is essential to the structure of reality, and time travel to the past would seem to violate it. Some theories suggest that time travel to the past could create a causal loop, where the timeline continuously feeds into itself, creating a consistent version of events. Others propose that, rather than changing the past, time travel might only observe the past, or that any changes would have predetermined consequences, meaning that events would unfold in a way that ensures consistency across timelines. 2. The butterfly effect. The concept of time travel often invokes the butterfly effect, a term popularized by chaos theory. The butterfly effect suggests that small changes in the past can lead to disproportionately large consequences in the future. A time traveler could inadvertently make a minor change, like stepping on a butterfly in the past, that causes a chain of events to unfold, resulting in drastic alterations to the future. In theory, any minor change, whether it's altering a small historical event, meeting a different person, or even changing the order in which events unfold, could dramatically shift the course of history. This could create a parallel timeline where the future we know no longer exists, or it could cause significant instabilities in reality itself. While the butterfly effect is often discussed in theoretical terms, it demonstrates how delicate and interconnected the fabric of time can be. 3. The many worlds. Interpretation. One way to resolve paradoxes like the grandfather paradox is the many worlds interpretation of quantum mechanics. According to this theory, when a time traveler makes a change in the past, it doesn't affect the original timeline. Instead, it creates a new, parallel timeline or universe in which the change occurs. In this model, every action, whether it's changing the past or choosing a different path, would create a branching of realities. This theory allows for multiple timelines to coexist without contradictions, where time travel to the past doesn't disrupt the flow of events in the original timeline. Instead, it generates a new timeline, perhaps one that runs parallel to the original. If you went back in time and prevented your grandfather from meeting your grandmother, you wouldn't erase your own existence, but rather create a new timeline where you never existed. The original timeline in which you were born remains unchanged. The many worlds interpretation solves the paradoxes associated with time travel, but introduces its own set of challenges. It suggests that every action could potentially create an infinite number of alternate realities, each with its own version of events. This implies that every moment in time is a fork, creating endless possible futures, where every choice or change leads to a new timeline. 4. ethical and social implications. If time travel were to become a reality, it wouldn't just affect the fabric of time and space. It would have profound ethical and social implications. What if people could travel to the past and alter historical events? Could someone go back in time to prevent atrocities like wars or genocides? While the idea of fixing the mistakes of the past is tempting, it raises the question: who decides which events are worth changing? And how would we deal with the consequences of altering the past? Even small changes could have unintended consequences, and those who wield such power could potentially create a future that serves only their interests. Furthermore, time travel could introduce social and political challenges, as people might use it to gain unfair advantages or exploit the knowledge of the future. Would time travel lead to a new form of social inequality, with a small group of elites having access to the ability to manipulate time for personal gain? Or would time travel be regulated, and how could society ensure that it's used responsibly? 5. Time travel and the nature of existence. Beyond the practical and ethical consequences, time travel raises questions about the very nature of existence. If you could travel through time, would you still be the same person who left the present moment? Or would you become something different due to the experiences you've had while traveling? Would it be possible to experience multiple versions of yourself, existing in different timelines or realities? And how would that affect your sense of identity? Now that we've examined the potential consequences of time travel, including paradoxes, the butterfly effect, and ethical dilemmas, it's time to turn our attention to the future of time travel. Could we one day make the leap from theoretical concepts to real, practical time travel? While the road ahead is filled with obstacles, advancements in physics, technology, and quantum research could bring us closer to making time travel a reality. However, the journey from theory to practice is complex and uncertain. 1. The role of quantum physics. Quantum physics could play a crucial role in unlocking the secrets of time travel. As we've seen, quantum mechanics challenges many of our traditional ideas about time and space. Phenomena like quantum entanglement, superposition, and quantum tunneling offer tantalizing glimpses into how particles behave in ways that defy classical physics. Some scientists believe that understanding these quantum phenomena at a deeper level could open the door to manipulating time. For example, quantum entanglement suggests that particles can be connected across vast distances, potentially allowing instantaneous transfer of information or even matter across space-time. While it's still a far stretch to suggest that quantum entanglement could lead to macroscopic time travel, the principles of quantum mechanics might provide the foundation for future breakthroughs in time travel technologies. Quantum computers, which harness the principles of quantum mechanics to process information in fundamentally new ways, could also provide the computational power necessary to simulate and manipulate space-time at incredibly small scales. As our ability to control quantum systems advances, it could eventually lead to the development of quantum time travel devices or methods, allowing for time manipulation in ways we can barely imagine. 2. Advancements in space travel. Another avenue that could eventually lead to time travel is the advancement of space travel technology. The idea of traveling at relativistic speeds, or close to the speed of light, is central to the concept of time dilation. If humanity were able to develop spacecraft that could travel at such speeds, we could, in theory, experience time differently from those on Earth, allowing for forward time travel. Currently, we are far from achieving speeds anywhere near that of light, but recent developments in space propulsion technologies, such as ion engines and nuclear fusion, could one day make high-speed space travel a reality. If a spacecraft were to approach significant fractions of the speed of light, time dilation would allow astronauts to travel forward in time, experiencing only a few years while decades or centuries pass on Earth. Even more advanced propulsion systems, like theoretical warp drives, such as the Alcubierre drive, have been proposed. These concepts would involve bending space-time around a spacecraft in a way that allows faster-than-light travel without violating the laws of physics. While such technologies are still in their infancy, they highlight the potential for future breakthroughs in our understanding of how to manipulate space-time for time travel. 3. Exploring wormholes and black holes. As we've already mentioned, wormholes remain one of the most exciting prospects for time travel. These hypothetical tunnels through space-time could, in theory, connect different points in time and space. The biggest challenge, as we know, is that wormholes require exotic matter to keep them stable, and such matter has never been discovered. However, advancements in quantum field theory and high-energy physics might one day reveal new forms of matter or energy that could stabilize wormholes long enough for travel. The discovery of dark matter and dark energy, two of the most mysterious components of the universe, could also hold the key to understanding how to create the necessary conditions for wormholes. If scientists can uncover more about the properties of these enigmatic substances, they might unlock the ability to create or harness wormholes for time travel. Similarly, black holes could offer insight into time travel despite their deadly nature. As we learn more about the inner workings of black holes, such as their role in information paradoxes and the structure of space-time, we may discover ways to use the intense gravitational forces around black holes to manipulate time or even to access parallel universes or alternate timelines. 4. Artificial intelligence and time travel. In addition to advances in quantum physics and space travel, artificial intelligence, AI, may play an unexpected role in the development of time travel. AI could assist in solving the complex mathematical models required to understand and manipulate space-time. Quantum computers and AI working together could provide the computational power needed to simulate the extreme conditions of time travel, predicting the behaviors of particles, gravitational forces, and the structure of space-time under different scenarios. AI could also aid in controlling and managing time travel technologies. As we develop technologies that may one day allow us to manipulate time, we'll need systems capable of managing the immense complexity involved. AI's ability to process vast amounts of data and make real-time decisions could be vital in ensuring the safe operation of time travel devices. 5. The ethical and social challenges. As time travel becomes more feasible, it's crucial to consider the ethical implications. Time travel could open up a world of possibilities for both good and evil. If we could manipulate time, would it be ethical to alter historical events or change the future? Could time travel be used to right historical wrongs, or would it create unforeseen consequences? As we continue to explore the future of time travel, the critical challenge is transforming theoretical physics into practical technology. While time travel is grounded in well-established scientific principles, there are still significant technological and ethical challenges to overcome. Let's focus on the critical steps toward making time travel a reality. 1. Quantum computing and simulations. The development of quantum computing could play a pivotal role in realizing time travel. Quantum computers harness quantum mechanics to perform calculations that classical computers cannot, allowing us to simulate complex phenomena like space-time distortions, wormholes, and black holes. These simulations could provide deeper insights into how these effects might be manipulated, helping physicists refine the necessary theories to make time travel possible. The precision offered by quantum computing could open up new ways to test and explore time travel scenarios, accelerating advancements toward practical time travel. 2. Advancements in space travel. One of the most plausible routes to time travel is through high-speed space travel. Time dilation, which occurs when an object moves at relativistic speeds, close to the speed of light, could allow astronauts to experience time at a slower rate compared to people on Earth. Current propulsion technologies, like ion engines and nuclear fusion, aren't capable of reaching relativistic speeds yet, but they represent significant advances in space exploration. Achieving these speeds could allow astronauts to travel forward in time, experiencing only a short amount of time, while decades or centuries pass on Earth. Moreover, concepts like the Alcubierre drive offer a theoretical method for faster-than-light travel by bending space-time. The Alcubierre drive proposes that a spacecraft could be carried within a bubble that distorts space-time, allowing the ship to travel faster than light without actually moving through space. While this technology remains theoretical, its development could eventually enable time travel by bending the fabric of space-time itself. 3. Creating and stabilizing wormholes. Another potential method of time travel lies in wormholes, theoretical tunnels in space-time that could connect two distant points, possibly in both time and space. To make wormhole travel possible, we'd need to stabilize these tunnels using exotic matter that has negative energy, which counteracts the forces that would collapse the wormhole. While exotic matter has never been discovered, advances in quantum field theory, dark energy, and dark matter research might reveal new possibilities for stabilizing wormholes. If we could stabilize them, wormholes might offer a pathway for not only interstellar, but time travel as well. 4. Artificial intelligence, AI, and time travel. Artificial intelligence could play a critical role in the development and management of time travel technology. AI's ability to process vast amounts of data, simulate complex scenarios, and perform real-time calculations could be invaluable for managing the delicate balance of time travel. For example, AI could be used to navigate and stabilize wormholes or manage spacecraft traveling at relativistic speeds, ensuring safe travel through time and space. Moreover, AI could help monitor the ethical implications of time travel, ensuring that it is used responsibly. Additionally, AI could assist in predicting the consequences of time travel decisions, helping mitigate the unintended effects of altering history or creating parallel timelines. AI's predictive models could guide us in making informed decisions about when and how to use time travel, minimizing potential risks. 5. Ethical and social implications. The possibility of time travel raises profound ethical and social questions. Who controls time travel? Should governments or international bodies regulate it? If time travel becomes possible, would it be used for good, such as correcting historical injustices, or misused for personal gain? The potential for historical alteration, creating parallel realities, or preventing disasters could be both beneficial and disastrous. Ethical questions arise, especially around accessibility. Time travel could become a tool for the wealthy or powerful, exacerbating inequalities and allowing for manipulation of events for personal advantage. Governments would need to establish strict regulations to ensure time travel is used fairly and responsibly. In the wrong hands, time travel could reshape history in ways that cannot be undone. 6. Time travel and consciousness. One of the more intriguing questions is how consciousness would work in a time travel scenario. If you travel to the past or future, would your consciousness shift to a version of yourself in that time? Could you interact with your past or future self, or would you simply observe events as an outside observer? The nature of consciousness is still not fully understood, and the ability to travel through time might force us to rethink identity and self-awareness. In addition, how would time travel affect human memory? Could the act of interacting with the past change your memories of events, creating a feedback loop that alters your perception of history? These questions delve into the intersection of psychology, philosophy, and physics, and they would need to be explored as time travel becomes more feasible. 7. Technological convergence for time travel. The future of time travel will likely require a convergence of various technologies working together. As quantum computing, advanced propulsion systems, and AI progress, we might reach a point where these fields merge to enable time travel. Each technological breakthrough in space exploration, quantum mechanics, and AI could build on the previous one, gradually unlocking the possibility of manipulating time. As we continue to explore the consequences of time travel, one of the most significant questions is the impact of changing the past. If time travel were possible, altering events from history would raise not only philosophical questions about causality, but also deeply ethical dilemmas about the use and misuse of such power. 1. The butterfly effect. The butterfly effect, a concept from chaos theory, suggests that even small changes in the past can lead to enormous consequences in the future. The idea is that a minor action, like stepping on an insect in the past, could eventually set off a chain of events that drastically changes the course of history. This idea emphasizes how delicate and interconnected time is. Even a seemingly insignificant alteration could ripple across the timeline, causing unintended and often unpredictable outcomes. The butterfly effect raises the question, could we control the consequences of our actions in the past, or would we be at the mercy of the infinite possibilities it creates? 2. Historical responsibility and ethical choices. With the ability to alter the past, time travelers would wield immense power. Should time travelers be allowed to prevent wars, stop disasters, or correct injustices? The ethical challenges here are immense. Should they be able to change history for the greater good? Or would there be significant dangers in giving one person or group the power to control history? The potential for abuses is obvious. For example, people could manipulate the timeline for personal gain, altering events to serve their interests. The ethical implications of these choices would require careful thought and regulation. Who decides which events are worth changing? And how would society prevent the misuse of time travel technology? 3. Fixed timeline versus multiverse. One potential resolution to the paradoxes of time travel is the fixed timeline theory, which posits that time is immutable. No matter what a time traveler does, the events of history will always unfold in a way that preserves the timeline. In this model, even if you tried to change the past, events would still occur in a way that ensures the timeline remains consistent and unchanged. Another possibility is the multiverse theory, which suggests that when a time traveler changes the past, it creates a parallel timeline or alternate universe. Each action, no matter how small, could create a new branch of reality. While this theory offers an explanation for how time travel could work without creating paradoxes, it also raises profound questions about the endless number of possible timelines that could exist. Each timeline could diverge further and further, creating an infinite multiverse of possibilities. 4. Temporal paradoxes and self-consistency. Temporal paradoxes, such as the bootstrap paradox, occur when actions in the past create contradictions in the present. For example, if you went back in time and gave Shakespeare a copy of his own plays, would that mean he plagiarized himself? The theory of self-consistent time travel suggests that the timeline would adjust itself to prevent paradoxes from occurring. In this scenario, any attempt to change the past would somehow result in events playing out in a way that maintains consistency. For example, you could travel back in time and try to prevent a disaster, but your actions would unknowingly ensure that the disaster still occurs, preserving the original timeline. 5. Time travel and personal growth. Time travel could have profound effects on personal growth. Imagine being able to revisit pivotal moments in your life, perhaps correcting mistakes or choosing different paths. While this might seem appealing, it raises the question of identity. If you could continually change your past, would you still be the same person? Would personal growth be hindered by the ability to fix mistakes instead of learning from them? Overcoming challenges and learning from failure is an essential part of growth. So, would time travel ultimately lead to a stagnation of personal evolution? Would we risk becoming trapped in an endless loop of trying to fix our mistakes without ever moving forward? As we continue our exploration of time travel, it's important to consider the practical challenges of making time travel a reality. While the theoretical concepts are fascinating, turning them into real-world technology is no simple feat. In this segment, we will focus on the scientific, technological, and ethical hurdles that would need to be overcome to make time travel feasible and explore the potential consequences of achieving it. 1. The laws of physics and time travel. The first hurdle to time travel is the fact that our current understanding of physics, while sophisticated, doesn't easily allow for it. Einstein's theory of relativity, which is fundamental to our understanding of space-time, provides the framework for much of the theoretical work on time travel. It suggests that time and space are interconnected in a way that could allow time travel under the right conditions. However, manipulating space-time requires such extreme energy levels and conditions that we currently have no means of achieving them. One of the most discussed possibilities for time travel lies in wormholes. These hypothetical passages through space-time could, in theory, connect distant points in space or time. However, they would require exotic matter with negative energy to remain stable, and such matter has not yet been discovered. Until we find a way to harness such forces, creating a wormhole or stable time portal remains purely speculative. 2. Technology required for time travel. Even if the physics of time travel were understood, the technology to make it happen would be incredibly advanced. Propulsion systems capable of reaching relativistic speeds, close to the speed of light, would be essential. Currently, even our fastest spacecraft travel at a small fraction of the speed of light. The required energy to reach such velocities would be astronomical, and our current energy sources simply aren't capable of providing that much power. Similarly, creating and stabilizing a wormhole would require technological innovations that are far beyond our present capabilities. Imagine a machine powerful enough to bend space-time itself, manipulating gravitational forces and exotic materials on an unimaginable scale. This kind of technology would not only need to exist, but also be under precise control to avoid catastrophic failure. 3. Ethical and social implications. If time travel becomes possible, it would have profound ethical and social consequences. The ability to alter history would give individuals or groups enormous power over the future. Who would regulate such technology? How would the misuse of time travel be prevented? Could time travel be used to prevent global crises, or could it be used for personal or political gain? One of the biggest ethical questions is whether humanity should ever possess the ability to rewrite history. While it might seem noble to correct the mistakes of the past, even well-intentioned changes could have disastrous consequences. Time travel could also create vast social inequalities, with only certain people or organizations having access to it, leading to a new kind of power imbalance in society. Furthermore, altering events in the past could have irreversible consequences. Would the world, as we know it, still exist if significant moments in history were changed? The butterfly effect suggests that even minor interventions could lead to unpredictable and potentially catastrophic outcomes, making the ethical implications of time travel even more complex. 4. The human mind and time travel. Another consideration is how human beings would handle the psychological effects of time travel. If we were able to travel through time, would we be able to comprehend the full impact of our actions? The ability to witness past events could lead to a heightened sense of responsibility. But living through multiple versions of reality could take a toll on mental health. For instance, how would someone react if they could revisit their past but alter the outcomes? Would it lead to personal growth, or would it become a perpetual cycle of regrets and second chances? The human mind may not be equipped to handle the complexity of interacting with time, especially with the potential for creating multiple timelines or parallel universes. The consequences for identity and self-perception could be profound. 5. Regulating time travel. In a world where time travel is possible, there would need to be strict regulation to ensure that it is used responsibly. Given the potential for abuse and the devastating consequences of misusing time travel, governments or international bodies would need to establish laws and rules to manage it. These regulations would need to address not only who has access to time travel, but also how and when it should be used. Would time travel be limited to certain individuals, like government officials or scientists, or would it be democratized for the public? Who would have the authority to approve changes in the past? And would there be oversight to ensure that the consequences are fully understood before any action is taken? The global legal framework for time travel would likely be complex, involving multiple nations and governing bodies to prevent misuse and ensure fairness. 6. The future of time travel. Despite the current obstacles, time travel is still a possibility that intrigues scientists and researchers. As our understanding of physics evolves and our technological capabilities advance, we may one day unlock the secrets of space-time. If we can find a way to manipulate gravitational forces, discover exotic matter, or build advanced propulsion systems, the dream of time travel could become a reality. As we look ahead, the potential of time travel offers both immense opportunity and responsibility. While we've explored the scientific, ethical, and technological hurdles of time travel, let's now turn to the possibilities of what time travel could bring if it became a reality. How could it reshape our understanding of the universe, history, and humanity itself? 1. Rewriting history and preventing disasters. One of the most profound possibilities of time travel would be the ability to correct past mistakes. The opportunity to prevent disasters, wars, or atrocities could radically reshape human history. Imagine stopping climate change before it became a global crisis, or averting conflicts that led to widespread suffering. The ability to intervene in history could serve as a powerful tool for humanitarian good. However, such power comes with immense ethical concerns. Altering the past might erase the lessons we've learned from those mistakes. While correcting the past might seem noble, it could also lead to unintended consequences. Even well-intentioned changes could spiral into unforeseen outcomes, challenging the very fabric of history. 2. Exploring the future. While altering the past presents significant challenges, the ability to travel to the future offers intriguing possibilities. If time travelers could witness the results of today's actions, we could better understand the long-term effects of our choices. Technological advancements in areas such as medicine, space exploration, and social development could be seen in the future, giving us valuable insights into where humanity is headed. However, this ability to observe the future raises questions about free will and determinism. If we can see the future, does it become fixed, or can we still influence it? Could we, by observing it, alter the course of events without realizing it? If the future can be witnessed and changed, could we lose our agency over our own future, becoming mere spectators of our destiny? 3. Accelerating technological innovation. Time travel could significantly accelerate technological progress. Imagine scientists and engineers traveling forward in time to witness the outcome of their work, then using that knowledge to improve their designs or avoid past mistakes. This feedback loop would push innovation at an unprecedented rate. For example, with time travel, medical advancements could be accelerated by seeing future developments and adjusting research accordingly. The ability to peer into the future of space exploration could provide us with the data needed to overcome current technological barriers. This acceleration, however, would need to be carefully controlled to avoid exploitation or misuse. 4. Social and ethical impacts. The social effects of time travel would be as significant as its technological possibilities. If time travel were accessible to a select few, it could widen existing inequalities. Those with the ability to travel through time could alter the past or shape the future to benefit their own interests, leaving others behind. This could lead to social divisions between those who control time and those who do not. The ethical implications of time travel would also be far-reaching. If individuals or governments controlled time travel, there would be a need for strict regulation. Who gets to decide what changes are made? Could political elites use time travel to control history, or should it be reserved for collective human progress? These issues would need to be addressed carefully to ensure that time travel is used responsibly. 5. Immortality and the human condition. One of the most existential implications of time travel is the potential for immortality. If we could continually revisit the past or visit the future, could we escape the natural cycle of life and death? Time travel might offer the ability to relive past experiences or extend life, but would this diminish the value of life itself? Would immortality lead to stagnation in personal growth, where we could live the same moments repeatedly without the natural process of aging and learning? Could the human experience lose its meaning if we are no longer bound by time? The inevitability of death shapes much of what we do and how we value our moments. If time travel removes this boundary, it may fundamentally change the way we view existence and purpose. 6. Time travel and the nature of consciousness. Time travel also challenges our understanding of consciousness. Would our mind remain anchored in the present, or could we move through time with our consciousness intact? If we traveled to the past or future, would we carry our memories with us, or would we become different versions of ourselves? Exploring these questions raises deep philosophical concerns. If we could shift our consciousness across different timelines, would we still be the same person? Would time travel allow us to experience multiple lives, and if so, what would that do to our sense of identity? These questions go beyond the realm of physics and delve into the nature of the self. 7. Regulating time travel. If time travel becomes a reality, global regulation would be necessary. Without oversight, time travel could lead to serious abuses. Who would decide what changes to the past are acceptable? Could powerful entities alter the future for personal gain? Strong international laws would need to be created to govern the use of time travel, ensuring it is used to benefit humanity and not to exploit it. Building on our discussion of the possibilities and implications of time travel, we now turn to the scientific mysteries and unanswered questions that still surround this fascinating concept. Despite significant advances in physics and technology, many aspects of time travel remain theoretical and unexplored. This segment dives into the frontiers of research, exploring what science still doesn't understand and where future discoveries might lead us. 1. The nature of time itself. Time is one of the most fundamental yet mysterious aspects of the universe. Physicists often describe time as the fourth dimension, intertwined with the three dimensions of space to form space-time. However, despite this understanding, the true nature of time remains elusive. Is time linear, flowing steadily from past to future? Or could it be more flexible, with loops, branches, or even multiple timelines existing simultaneously? Understanding time is critical to unlocking the secrets of time travel. Some theories, like loop quantum gravity and string theory, suggest that time might be granular or quantized at the smallest scales, rather than smooth and continuous. Others propose that time might be an emergent property arising from more fundamental aspects of reality. Without a complete understanding of time, any attempt at time travel will remain speculative. 2. Quantum mechanics and time travel. Quantum mechanics, the physics of the very small, challenges our classical ideas of reality and causality. Phenomena like quantum entanglement, superposition, and tunneling suggest that particles can behave in ways that seem to transcend time and space. Could these quantum effects be harnessed to enable time travel? One of the intriguing possibilities is that quantum mechanics might allow for time loops or closed time-like curves on very small scales. These loops would permit particles to travel back and forth in time, possibly allowing information, or even matter, to move through time in ways that classical physics forbids. However, extending these ideas to macroscopic objects, like humans, remains a huge challenge. 3. The grandfather paradox and quantum solutions. As we've discussed before, the grandfather paradox is a fundamental problem for time travel. But some physicists believe that quantum mechanics may offer solutions. The many worlds interpretation suggests that when you travel back in time and change an event, you create a new, parallel universe where that change occurs. This way, paradoxes are avoided because the original timeline remains intact. Other proposals involve self-consistent solutions, where events adjust themselves so that paradoxes never occur. These ideas remain theoretical and are the subject of ongoing research, highlighting how much we still have to learn. 4. Black holes and wormholes, cosmic gateways. Black holes, with their intense gravity and mysterious interiors, remain one of the most promising cosmic phenomena related to time travel. Some theories suggest that the singularity at the center of a black hole might connect to another point in space-time, potentially acting as a gateway or shortcut through the universe. Similarly, wormholes, hypothetical tunnels through space-time, could theoretically link distant parts of the universe or different times. However, wormholes require exotic matter to keep them stable, and we currently lack evidence that such matter exists. Studying black holes and searching for wormholes is a major focus of modern physics and astronomy. Future discoveries may reveal whether these cosmic objects could one day be harnessed for time travel. 5. The role of dark matter and dark energy. Most of the universe is made up of dark matter and dark energy, mysterious substances that we can't directly observe, but which influence the universe's structure and expansion. Some scientists speculate that these mysterious components could play a role in manipulating space-time. Understanding dark matter and dark energy could be key to discovering new physics that would enable time travel. They might help us find the exotic matter needed for wormholes or reveal new ways to bend space-time. 6. The limits of technology and knowledge. Despite all these fascinating possibilities, it's important to remember that time travel remains theoretical. We have no technology capable of manipulating space-time at the scale required, and many of the fundamental questions about time and causality remain unanswered. The path to practical time travel will likely require breakthroughs in physics, technology, and our understanding of the universe. Continued research in quantum physics, cosmology, and astronomy is essential. For now, time travel remains a concept that pushes the boundaries of science, inspiring imagination and driving scientific inquiry. As we dive deeper into the potential and challenges of time travel, we must address one final crucial question. What are the real-world implications of time travel on society, politics, and human nature? Beyond the scientific and technological challenges, time travel could dramatically reshape the way we live, govern, and relate to each other. In this segment, we explore how time travel could transform society, individuals, and the global order. 1. Time travel and politics. The political implications of time travel are profound. Imagine a world where nations or governments have access to time travel. The ability to travel into the past would give political leaders and military powers the potential to rewrite history for their benefit, potentially using time travel to manipulate elections, wars, or diplomatic outcomes. Political agendas could be dramatically altered with even the smallest intervention in the past. Would time travel be regulated by governments or international bodies, or would it be privatized, leading to a new form of corporate control over history? If time travel could be used to prevent wars, end conflicts, or stop atrocities, it could be an unparalleled force for good. However, it could also be used to further entrench authoritarian power, leading to global instability. The ability to alter past events would likely trigger a new arms race in time travel technology as nations fight to gain control over the flow of history. 2. Social stratification and time travel. One of the most significant social impacts of time travel would be the creation of a new form of inequality. If access to time travel were controlled by a few, it could create a two-tier society: those who can travel through time and those who cannot. The elite with access to time travel might manipulate history to preserve their status, wealth, and power. For instance, time travelers might exploit past events for personal or financial gain, influencing economic markets or making strategic decisions that benefit them across multiple time periods. This would deepen the divide between the privileged and the underprivileged, giving the wealthy control over time, allowing them to accumulate wealth and power indefinitely. The rest of society could find itself disenfranchised, watching as history is rewritten by a select few. Further, if time travel were to become widely accessible, how would society adjust to interacting with different versions of reality? Would people who travel to the past become more detached from the present? Or would they lose touch with the world they originally came from? Cultural and societal values would undoubtedly shift as people experience multiple timelines, leading to an identity crisis or a fragmentation of collective memory. 3. Personal identity and time travel. The personal implications of time travel are as profound as the societal ones. Would traveling to the past or future make us more connected to ourselves, or would it lead to an identity crisis? Imagine a world where you could constantly revisit your past, correcting mistakes or reliving your best moments. Would this make people feel fulfilled, or would it erode personal growth? The nature of memory would be fundamentally changed. If people could visit different versions of themselves or interact with their past, would they retain the same sense of self? Would the self be fluid, changing as they alter past decisions? Or would there still be a core sense of identity that remains constant despite the ability to change one's personal timeline? Time travel could also impact our perception of life's meaning. Would the knowledge that we could revisit any moment in time diminish our appreciation for the present? Would people start to view their lives as a series of rehearsals, knowing they could always go back and make different choices? 4. Ethics of time travel. Who decides what to change? One of the greatest ethical challenges with time travel is determining who gets to decide what gets changed. If humanity had the power to alter history, who would have the right to make those decisions? Should the people govern time travel, or would it be left in the hands of governments or corporations? The ethical oversight of time travel is critical. There would need to be strict guidelines on what constitutes acceptable changes and what would be considered unethical interference. For instance, would it be ethical to travel back in time to prevent a crime, but unethical to alter an individual's personal life or decisions? Could time travel be used to correct historical injustices, or would it be better left untouched to preserve the integrity of our historical lessons? 5. Time travel as a catalyst for global change. If time travel became a reality, it could act as a catalyst for global change. If humanity could change past events to prevent disasters, it might lead to a more sustainable future. We could stop climate change, prevent global conflicts, or avoid the overexploitation of resources. The ability to change the course of history could lead to global cooperation and perhaps even a new age of enlightenment. But there's also a risk that global time travel could lead to a new form of control, one in which powerful elites manipulate time for their benefit. How would society ensure that time travel benefits all people, rather than a select few? Could democracy and freedom thrive in a world where time itself could be altered at will? 6. Time travel and the evolution of human nature. Finally, the ability to travel through time could change the very nature of humanity. As we gain the ability to experience different timelines, human evolution might take on new meanings. Could time travel technology help us better understand our place in the universe, or would it lead to unpredictable consequences that change human nature forever? As we continue our exploration of time travel, it's important to understand its real-world consequences on society, politics, and human relationships. While time travel may offer significant opportunities, it could also present challenges that humanity might not be prepared for. This segment focuses on how time travel could reshape the fabric of human society, both in terms of practical applications and ethical considerations. 1. Time travel and global power dynamics. The ability to alter the past could shift global power dynamics in dramatic ways. If time travel were accessible to governments, corporations, or individuals, it could potentially lead to conflict or manipulation of the timeline for personal or political gain. Nations with time travel technology could manipulate historical events to shape outcomes in their favor, influencing international relations and global power structures. Such manipulation could extend to areas like economic markets, where time travelers could exploit past events for financial gain, or even political elections, where the timeline could be altered to ensure the election of a particular candidate or the success of a political movement. This presents a dangerous power imbalance, where only certain individuals or groups hold the keys to shaping history. The potential arms race in time travel technology could trigger a global struggle for control of time itself, leading to greater geopolitical instability. 2. Time travel and inequality. If time travel becomes a reality, it could further deepen societal inequalities. The ability to revisit the past or manipulate the future would likely be limited to the wealthy, the elite, or those with access to advanced technologies. This could create a two-tier society where a small, privileged group has the power to reshape history to their benefit, while the majority of people have no control over their own timeline. The prospect of exploiting time for personal gain could exacerbate existing inequalities in society, as those with access to time travel could continue to accumulate wealth and influence by revisiting profitable moments in history, while the rest of humanity remains static. This could lead to a division between those who control the flow of time and those who are left behind. 3. Personal growth and time travel. On a personal level, time travel could have profound effects on identity and personal growth. Would the ability to revisit moments of our lives, whether to correct mistakes, relive experiences, or alter the course of events, enhance our understanding of ourselves or hinder it? Reliving moments or correcting past mistakes could offer temporary relief, but it might also prevent us from truly learning from our past. Personal growth is often the result of facing challenges and making mistakes. With the ability to change the past, would we become trapped in a cycle of constantly revisiting the same moments, never allowing ourselves to evolve beyond them? Moreover, if people can travel through time, they might become detached from their sense of self as they lose touch with the continuous nature of their lives. Rewriting your personal timeline could cause confusion about who you truly are and what your role in the world is. 4. Ethical oversight of time travel. If time travel is to be a tool for humanity, its ethical oversight becomes absolutely critical. Who should control time travel technology? Would it be in the hands of governments, private corporations, or would it be democratized for all to use? Establishing global regulations to govern the ethical use of time travel would be necessary to ensure that the power to alter history isn't abused. Issues like historical manipulation, financial exploitation, and personal interference would need to be carefully monitored. Who decides what events are worth changing, and what safeguards would prevent time travel from being used to benefit only a select few? One possible solution could be the creation of an international body to regulate time travel, ensuring that any alterations to the timeline are thoroughly considered and their consequences carefully evaluated. Time travel could offer immense potential for good, but without oversight, it could lead to global chaos. 5. The evolution of human consciousness and time travel. The ability to manipulate time could change the very nature of human consciousness. If we could visit the past, alter the future, and live through multiple versions of our lives, how would this affect our understanding of identity and selfhood? Constantly traveling through time could lead to a fragmented sense of self, where consciousness is no longer anchored to a single moment in time. If people could live in different realities or revisit different points in their own history, it might be difficult for them to maintain a coherent sense of who they are. Could this shift in consciousness lead to emotional or psychological instability? What would happen if humanity, instead of evolving naturally, became obsessed with the ability to control time, leading to a society where individuals are more connected to their pasts than their present, unable to fully live in the moment? 6. The future of humanity in a world of time travel. The most exciting and terrifying question about time travel is how it will shape the future of humanity itself. If time travel were to become a common practice, it could enable humanity to prevent disasters, avoid wars, and correct injustices. It could bring global cooperation or unprecedented innovation, where ideas and technologies are shared across time. Scientific discoveries could be expedited, allowing humanity to solve crises like climate change or poverty more effectively. Thank you for joining me here at the Midnight Physicist. I hope tonight's journey through the universe has sparked your curiosity and helped you drift a little deeper into wonder. If you enjoyed this exploration, make sure to subscribe and hit the notification bell so you never miss a cosmic adventure. Until next time, keep dreaming, keep exploring, and remember, the universe is just a thought away. Sleep well, and I'll see you in the next one.